Hey there everyone. In this video we are going to study significance levels. So this has to do with hypothesis testing. So we're going to look a little more in depth about this significance level alpha that we keep talking about when we deal with hypothesis tests. And so this video will introduce us to some of the concepts related to it. A little bit of it will be review. And then in the second video we'll actually look at some examples. So first, some vocabulary. So we have to recall that the test statistic is the value in a probability distribution that is used to make a decision about the null hypothesis. And so remember the test statistic, when we're dealing with means and proportions, to compute this, you have to use some of the techniques from chapter 7 dealing with the sampling distribution. And so then the fancy name for test statistic is really z-score. Okay. Now, if we're talking about the chi-square test, then we call it the chi-square test statistic. So it's not a z-score because it's a different distribution. Now we've got a phrase called statistically significant. This means that the test statistic is far enough away from the presumed parameter to conclude that it would be unlikely for it to occur by chance if the null is true. So what usually causes people to have a hard time understanding this is this last part of the sentence here, to conclude that it would be unlikely for it to occur by chance. So what this is saying is that something else must be giving us the results for this particular sample. That's what this is really getting to. And so that something else hopefully would be maybe whatever intervention is that we're trying to study. Maybe the context of the example is a new tutoring program or something, right, that's causing a desire to change. And lastly, we've got the level of significance itself, which we call alpha. And if you remember, in the fourth step of the hypothesis testing process, after you get the test statistic, you obtain a p-value. And remember that p-value itself is a probability. And so what we do is we compare that p-value to the level of significance, in other words, to alpha. Well, alpha itself is also a probability. So you're comparing two probabilities here. And specifically, it's the probability of making the error of rejecting a true null hypothesis. And this is talked about in the the confidence intervals section. Okay, if you, not confidence intervals, hypothesis testing error types. That's what I meant to say. The confidence intervals is the next note here with alpha equals 1 minus c that you've seen when we talked about confidence intervals in chapter 8. So sorry about that. So alpha is the probability of making the error of rejecting a true null hypothesis. So that's dealing with error types, which we talked about at the very beginning of this chapter. And alpha's formula is 1 minus c, which comes to us from confidence interval. So there is a relationship between confidence interval and this idea of the hypothesis test. So in addition to comparing the p-value to the level of alpha, there's another strategy that we can actually use, and it's known as looking at the rejection regions. Okay, so we've got this p-value we talked about, so it too is a probability specifically of obtaining a sample statistic as extreme or more extreme as the one we've observed in the data when the null is assumed to be true. So we know how that works. Now the text gives us two different methods for doing hypothesis tests, and really we've focused on the second one, which uses p-values, okay, which is all of my steps that we did. And there's actually another one that uses rejection regions, and so that's going to help us to understand a little bit more about this idea of the level of alpha, the level of significance. So we've got three different types of hypotheses that we can get. Okay, so this is not new information, but it is information that you have seen before. So this one on the top right, this is for if we have a left tail, okay, and the one on the bottom corner here on the right is if you have a right tail. So these are the one-sided tests. That should be familiar. And the one kind of on the left here is the two-tailed tests, as it indicates. And what you're going to notice is we've got this negative z alpha and z alpha. What the heck is that? Here's z alpha over 2. Okay, that should sound familiar. So what exactly are we saying? Well, the idea of rejection regions is somewhat simple in that it says the following. These z alphas that you see on the bottom here, these are your critical values. Okay, these are the critical values, if I can spell. And so what we're looking at is to see, okay, if that's the critical value that we get, then what exactly is the test statistic? If our test statistic falls in here or in here, then what we do is we reject the null. That's the region we talk about in terms of the rejection region. Okay, negative z alpha over 2, this deals with the critical value, that level of significance, that alpha level. If our test statistic falls in here, then we reject the null, and similarly here. And so this will be best illustrated with an example to provide some context, and that's coming again in the next video. So as a result, we also have a table of values. This should actually be familiar. This part of the table should be very familiar to you. You've seen this with confidence intervals, okay? And so what we've added is this fourth column, which is the two-tailed test. And so, for example, the most typical level of alpha we use is 0.05. Well, that's related to a 95% confidence interval. And so then that z alpha over 2, or the one-tailed test, is 1.645, or plus or minus 1.96. And again, I promise to put that into context when we look at some examples for context. And finally, we've got a key observation here. And you may remember me saying in the videos about this that the smaller that level of significance, that alpha is, the stronger the test. Now everybody says, well, why? What's really happening here? Well, I want you to think about this. If we make the level of significance smaller, right? We make alpha small. What that does is it actually decreases the size of the rejection region. It makes it smaller. Think about it as a target, okay? So right now the target's very large, but if I were to take the target and slowly walk away from you, now it gets harder and harder to hit. And so that's really the idea behind making that alpha level as small as possible, thereby making the test stronger. And so that's the basic idea that we have here. Now in the next video, we'll look in the context of some examples and see how that works.